Let's begin to explore the process for simulating a storm event and retrieving results. The first step is to define runtime controls. Select File from the main menu. Then click on the onepond.net file in the Recent Files list. Click on the Control menu command and the Chan Runtime Scenarios form will appear. A runtime scenario establishes specific conditions under which the stormwater system will be analyzed. Each scenario is identified by a short label and a descriptive title. The title is used for report labeling. A more complete description can be entered for each scenario to provide a broad summary of the conditions being modeled and parameters used during the simulation. There is no limit to the number of scenarios that can be modeled, and each scenario has its own set of time controls as well as optional support files and runtime overrides for rainfall. The tab dialog provides access to all of the runtime options. Time controls are used to specify the simulation start and end points, computational time increments, and database output interval. The Chan smartly assigns pre-selected time control values for balance performance and output resolution, so you really only need to assign the run duration. Still, advanced time control is available at the click of a button. We will discuss those options later. Let's take a look at the set of support files that can be assigned to each scenario. There are 5 types of external files that can be assigned. Monitor lists designate a subset of features to display at runtime. The tailwater file assigns time-varying boundary conditions specific to the scenario. The initial conditions file overrides starting water levels assigned in the model network. Runoff hydrographs, perhaps generated by another program, and off-site inflows, such as for a known inflow boundary condition, can be assigned separately. Rainfall overrides are frequently used to set the rainfall volume and duration for the scenario. These rainfall assignments override values that were individually assigned for each basin element in the model network. You can also adjust the antecedent moisture condition to account for prior day's rainfall, and Chan will adjust runoff curve numbers where they are used accordingly. Finally, it is important to always match the rainfall distribution to the assigned event duration. Each scenario can be assigned a unique set of controls, and you can quickly add and delete scenarios using the command buttons lining the bottom of the form. The command buttons also allow you to navigate through the scenarios. Click on the next command to move from the mean annual to the 25-year 24-hour storm event scenario. Remember, it's a good idea to assign meaningful scenario labels and titles, as they are used during retrieval and in reports generated by the retrieval system. Click on the Files tab to view external files that are associated with this scenario. Next, click on the Overrides tab to view rainfall overrides. Here you will see that the rainfall volume has been updated to reflect the 25-year 24-hour rainfall depth. This rainfall volume will be used to override the values previously assigned to all basins during model construction. Click the next command to review runtime control settings for the 100-year 24-hour storm event scenario. Once more, default time controls are being used with a 30-hour run duration. No external files are employed, and only the rainfall volume is being overridden for this simulation. With these scenarios defined, our stormwater model is now ready to go. The use of scenarios for assignment of external support files and rainfall overrides allows you to simulate a wide range of conditions using a single model network file. In the next tutorial, we will put Chan to work and run our stormwater model under each of these 3 scenarios. So please come back and we will discuss how to perform a storm event simulation using Chan.